Hi, everyone. Thanks for joining us for today's webinar. We are going to get started in just a minute. We have lots of people that are still joining. We have a pretty robust registration list today. So just as a courtesy, going to give it another minute and then we'll get started. Thanks, everybody. Okay, hello everyone, and thank you for joining us for today's webinar, Introduction to Kubernetes Security, which is being presented in partnership with Weaveworks. Our presenters today are Liz Rice from Aqua Security and Brice Fernandes, who's joining us from Weaveworks. So Kubernetes is fundamentally a complex system with lots of different potential attack vectors aimed at data theft, currency mining, and other threats. During this webinar, Aqua Security and Weaveworks will provide an overview of the current state of security-related features in Kubernetes, and then demonstrate how you can build a secure and reliable Kubernetes deployment pipeline with GitOps best practices and explore how to prevent common Git attacks. In addition, we'll be showing image scanning and briefly explore how to best prevent common Git attacks. We will take questions at the end of the session, but please do remember to enter them into the Q&A panel as they come to mind. I'd also encourage you to take a look at the handouts tab. We've left lots of good information there for you to download. We are recording this session, and a link to the recording will be sent to you shortly after the webinar concludes. Okay, that's it for housekeeping items. Brice, I'm going to hand things over to you.
Hi, good morning. Thank you. Yes, so welcome to this webinar. I think I'm just going to get started straight away, just dive in. I hope everybody's doing all right. So really, I want to talk about kind of GitOps security. And by that, I'm going to be concentrating mostly on operational security. How do you operate the cluster securely? And I think Liz is going to pick up in the second half of the webinar, and she's going to be talking about Kubernetes security itself. So I'm going to concentrate on secure operations, and Liz is going to concentrate on securing Kubernetes itself. So really what I want to talk you through is the GitOps model, which is an operations model that works for Kubernetes clusters. So the idea here is that we have our Kubernetes cluster, and traditionally you would have kubectl direct access to modify your cluster. Now there are lots of problems with that. One important one is it's really, really hard to track what's going on, who has access, how they get access, etc. So what we do instead is actually we stop people from getting direct access to operate the cluster, and we instead operate through a configuration repository. So the users will actually make changes to a configuration repository, and once that changes in the configuration repository, then there's a deployment agent that will bring the actual change to the cluster. So it's all driven through the configuration. So that's kind of the first step in kind of securing your operations is you track exactly what you're doing in a version control system. You're able to roll things back. And the deployment agent itself, you really don't want the security credentials to modify your cluster to live outside your cluster. So in practice, what you do is you actually put the deployment agent inside your cluster. So you can see here that I've moved the deployment agent from that actually is making modifications. And that's actually moved into the cluster itself. What that means is that there is no access to the cluster. The users don't really get access to the cluster. They don't have keys or credentials to access the cluster. Your CI pipeline, which is a favorite entry point for malicious code, doesn't have direct access to your cluster. Because typically there's a lot of issues with somebody getting access to your CI pipeline adding an image that they control into your CI pipeline, and then that gets deployed to the cluster. They're not really injecting malicious code into your images or your applications and your artifacts. They're just replacing it and adding one of their own. And so this kind of stops the issue because you don't really have direct access. All the changes are driven through configuration. So that's kind of the model you have is the user makes a change to a configuration repository, and then the configuration change is picked up automatically by some software agent, and that changes your cluster and updates your cluster. Naturally, your agent will require access to your image repository. So now the interface between your CI pipeline and your deployment pipeline is your configuration repository, which defines what's in Kubernetes, and I'll show you an example a little bit later, as well as your image repository, which has all the set of artifacts that you've created and validated. And you don't just move the state into your cluster, but what you actually really want to do is continuously check that the cluster matches the configuration you've created. So this is now a continuous checking, continuous monitoring for the state of the cluster to be consistent with what you've defined. So if there's any alerts, for example, any issues with the state diverging, let's say a malicious user has created a new service role or a new cluster role in your cluster, then that will immediately trigger an alert because the agent is continuously checking that the real state of the cluster, the running state, matches the configuration in the configuration repository. And so you'll get an alert in however you like, and you can take remedial action. The agent will also immediately take actions to reapply the correct configuration. So it reduces the time window. It reduces the time window during which a malicious user could actually access your cluster because his cluster role will be deleted almost immediately. So that's kind of like the four principles I've gone through that kind of embody GitOps. So the entire system is described declaratively. The desired system state is version in the version control system. Approved changes to the desired state are automatically applied, and software agents ensure correctness. So they ensure that your Kubernetes cluster converges to the correct configuration, and they will alert you if there's any divergence and take remedial action. So you see like the entire system is in Git, the desired state is version in Git, approved changes are applied automatically. And this is quite nice because now you have your changes in Git, you can use quite sophisticated approval techniques. So you have quite nice approval tools because the approval process can then rely on the pull requests, etc. It can be automated. There's lots of integration points for approval at the operations level. And finally, software agents ensure correctness. That's the control loop we've already talked about. So why do we care, right? We have this traditional pipeline where things are talking to each other and they have access and credentials. So when we move things to a GitOps way, we're actually removing a lot of that access, moving it into our security boundaries, and then we have a canonical desired state. So not only does it give us good kind of security properties for access control, but also it's a really great way of doing disaster recovery, right? If you have your entire configuration for your entire cluster in a configuration repository, creating a new cluster simply means reapplying that configuration somewhere else. So you can do disaster recovery on your entire infrastructure in a matter of minutes, right? You're not talking hours anymore, you're talking minutes, which is a real game changer. And you need to think about kind of what that means, because it's not just about disaster recovery, but it's also about ease of deployment. If a developer can respin your entire infrastructure, everything that's on your cluster, your entire set of applications in a new cluster, essentially within minutes, then it speeds up their development as well. And your operator will then can kind of make changes to that repository to change your cluster. And the idea here is that now you're moving the enforcement, the constraints and the controls into those changes. So you're controlling the changes that go into your kind of golden configuration repository. And that could only be a single branch. You don't have to control all the branch, it could just be the master branch. And Git will give you really, really good auditing and attribution. Some of the best I've seen out of any tool, really, in terms of auditing what happened, why it happened, and who made it happen, as well as seeing the kind of sequences of change and attributing the change to a particular person. So now we're moving a lot of our burden of security. We're really moving that into Git, right? We're moving the security burden into Git itself. So the question is, how do you secure your Git repository? How do you actually make that safe to use because it now becomes a very attractive target for malicious users. So the first one you really want to care about is making sure that identity, knowing who a user is strongly enforced, right? So you can do that through a variety of means, but one of them is signed commits. So you can sign a commit with a GPG key, which guarantees that the author of the key was signing the commit, or at least whoever had access to the private key. This is significantly improved if you use things like physical GPG keys. So you can get tokens for maybe $10 to $20 USB tokens. You can plug them into your machine, make a sign a commit. The private key never leaves the physical token, and then you can just pull out the key afterwards when you're done with that signature. So that's a very strong guarantee that the person who has that key made that commit and signed it. You can also use, and once you've done that, you really want to be checking those signatures if you have signatures. So now you run the code in your CI pipeline, in your tools. You can do things like run an admission controller that will double check that the signatures are correct, etc., etc., etc. So now you have that really, really strong identity guarantees, that attribution very strongly enforced. Now, a quick note here about what you should sign and what you shouldn't sign. This is a direct quote from Linus Torvalds, who actually kind of the main author of Git. So the idea here is that really what he's saying is don't sign every commit. It's a bad idea. You're automating it. Signing should be a manual process where a user, an actual person, is making a decision to say, yes, I trust this particular version. And you don't really need to sign everything because of the way Git is built. If you sign the very top commit, all the ones that led up to that commit, essentially you're also signing them with a single signature. So you don't need to kind of sign all of the commits. So really kind of think about it. Signing is a user's action. You don't want to do it automatically. It's a step that a person takes to say, I trust this, right? So it should be kind of fairly deliberate. Doesn't mean it has to be hard. It just has to be deliberate. The next step is you don't really want a user to be able to change the past, right? So the past is really important, and there are ways in Git where you can change the sequence of events that led to a particular place, and that's not what we want. So two things that you want to be doing here is preventing force pushers, that you can do that at your provider level. However you're hosting Git, even if it's just a bare server, this is still possible. You can prevent force pushers and back up your Git repository. Now, backing up your Git repository essentially means you clone the Git repository on a, say, daily, weekly, hourly basis, however you want. Git by default is distributed, so backing up something just means that you make a clone copy of it. And the next thing, you want to make it difficult for people to get rid of the security features you've implemented. And so one of the ways to do that is now you have this approach which is configuration driven in a Git repository. So now you should be thinking about, how do I configure my providers with that approach to ensure their security, so that I can get all the good benefits I've been talking about, things like state convergence on a correct state, alerts, attribution, etc., on my infrastructure itself. So for example, you can configure GitHub itself or GitLab itself using configuration hosted in a Git repository. And this is a kind of meta GitOps way of working. You're using GitOps to manage your GitOps configuration. And then it goes without saying, some of the standard stuff that we're talking about here, monitoring the Git providers' audit logs. Every serious provider is going to be sharing some audit logs that you can look through, that you can alert on, etc. Verifying commits to master, make sure that the signature is correct, make sure that the SHA keys are done correctly, which Git will do out of the box. And finally, the big one is don't use deprecated software, right? This applies here too, and it's a really big issue. The speed of development on Git when a vulnerability is discovered is really fast, so you'll get a fix quite quickly. But that means you need to be kind of up to date, and that goes with everything. These are some of the examples of issues that have occurred in the past. They were fixed, and they are certainly fixed in the latest version. But this is to give you an idea of that these things do happen. They happen in every software, so keep up to date. And have a kind of a policy to keep up to date as well. If you want to know more, grab this. There are two kind of good resources here. I believe that hardening Git for GitOps is in one of the handouts that we're giving out. So you should be able to have access to this ebook that goes through everything I've talked about in a lot more detail. So now what I'm going to do is I'm going to do a quick demo of a GitOps pipeline in practice, showing you kind of what's the user interface like, what does that actually feel like when you're using it. So I have a cluster here. So this is just a very simple cluster with some machines. I'm going to take a look at the controllers. So I've got some things on my cluster. Let me take a look at the default namespace. So I've got some workloads running on the cluster, nothing particularly interesting here. What is interesting is I've configured it to use GitOps so that any change I make to my configuration repository here will immediately take effect in my cluster. So let's take a look at, say, I'm not going to do the Helm demo. Let's go for the Mighty Fine application. Go to the application here, and you can see we have one replica. So what I can do is just change that replica count, make the commit. So let's change that to, say, 4 replicas. And I'm going to commit the change here directly. Now, in practice, if this wasn't a demo, what you'd actually do is you'd create a pull request, and then you'd go through an approval process. And that approval process could, in fact, be automated. Part of it could be automated. Let's say you have security policies that are fairly granular. You can encode those security policies with something like the Open Policy Agent, and then run this against your configuration. So you're now doing validation of the configuration before it ever gets merged, before it ever gets to your cluster. So you're preventing things at the configuration at the Git level. And then you can use the same policies on your cluster to run policy checking on the cluster itself with an admission controller. So bad configuration will never make it into your master branch. And if it should do, then that configuration will be picked up by the Kubernetes admission controller on the cluster itself and not be approved for deployment. Okay, so I've created my 4 replicas. What I'm hoping to see here is that when I go back here, I've got the controllers. I can go to the pods, and I should be able to see that we have 4 Mighty Fine pods here. And you can see one has 0 container, this particular one, and that's probably because it's just still spinning up. So that's the idea here. That's the idea of like having direct control over your infrastructure through the use of the Git repository, the configuration itself. Now, there are lots of things you can do to kind of do defense in depth on your operations. One of them is to, for example, I've got a little demo here of various things. This is an artifact that I'm creating. This is actually, in fact, the same artifact here, the Mighty Fine container. And when I was building the artifact, I've used security scanning. This is the micro scanner from Aqua, actually. So you want to kind of build security into your operations so that you kind of defend your infrastructure before the code ever gets into your infrastructure. That's the key here. Really, you want to be able to say that your pipeline up to your infrastructure is secure. And this is one great example of how you can integrate a scanner very easily with your build process. In this case, we're scanning the image, and we can see a lot of vulnerabilities coming up in our build process. So that's it. That's a very brief overview of kind of GitOps and how GitOps can kind of help you drive some security, and how it shifts some of the security concerns from direct access to actually controlling configuration, controlling access to configuration, and some of the things you need to do about that. So now I'm going to hand it over to Liz, who can kind of give you a much more detailed overview of kind of Kubernetes securities itself.
Thank you very much, Brice. I think that was a fantastically compelling introduction to GitOps, and in particular, some of the security advantages of adopting a GitOps approach to your deployment. Can somebody just confirm? Yes, now I can see that my screen has got shared, so that's good. I am going to run through a kind of broader picture of the current state of Kubernetes security and some of the things that you need to be aware of when you're deploying your Kubernetes cluster. There are, of course, lots of things that can go wrong from the point of view of being attacked. And the reason why there are many different things we need to take into account is simply because Kubernetes is a complex system. There are lots of different APIs, lots of different potential attack vectors, lots of ways in which an attacker could potentially try to attack your deployment. And what we're going to talk about in this sort of section of the webinar is how to make sure that your configuration is set up to reduce the likelihood that an attacker is going to find a weak spot, to make sure that your configuration is as secure as it can be, to make sure that you're following best practices in terms of the configuration of the cluster and of the application code that you're running in that cluster. So I don't want to scare you by talking about all these different attack vectors, but you do need to be aware that there are lots of different possible ways that the bad guys are trying to get into your deployment. Maybe about 18 months ago, there was a very famous case where Tesla's Kubernetes deployment got attacked by cryptocurrency miners. They had basically left their Kubernetes dashboard open to the internet, and that dashboard was set up with effectively cluster admin privileges. Now, since this time, a lot of things have improved. This was, really kind of an alarm call, I think, to say a lot of things need to be much more secure by default out of the box. So many things have been improved. In fact, the dashboard is not even installed by default by the kubeadm installer, at least. And many of the default configuration settings that you get from kubeadm and other installers have been made much, much more robust. So you're much less likely to find kind of gross configuration issues like leaving a dashboard open to the internet. But the kind of things that you need to think about in terms of configuration is making sure that the Kubernetes control plane APIs aren't accessible to unauthorized people. That involves making sure that the Kubernetes API itself is restricted, that the kubelets, because every node is running a kubelet, that API also needs to be configured correctly. And finally, the etcd store that's storing all the state configuration information. It's storing information about what pods, what nodes, what all the other resources are on your cluster. So we need to make sure that that's locked down, and that an attacker who somehow, if somebody does manage to get into your cluster somehow, there are additional layers of defense that they can't then attack your deployment through any of these APIs. Now, there are lots of different parameters involved in setting up these different servers, or different components rather. And out of the box, the defaults are pretty good now, as I say. But there are a few cases where you might want to maybe do something slightly different from the defaults. There's a guide to help you with these kind of best practices, and it's from the Center for Internet Security. So it's a Kubernetes benchmark from the CIS. And this benchmark consists of about 200 pages of guidance on how to best configure your Kubernetes cluster. It's that long because there are so many different settings, and it's essentially going setting by setting to say what the kind of received wisdom is on best practice for configuring those settings. Obviously, 200 pages of guidance would be pretty tedious to work through manually. So we built an open source tool called Kubench that you can run on your cluster to automate checking whether or not you're compliant with what the benchmark recommends. You might choose to not be compliant with every single one of those checks, but at least if you find something where you diverge from the benchmark, it gives you, it highlights it for you so that you can think about it, check whether in your environment it makes sense to meet the benchmark or perhaps have an exception in your environment. I would say the vast majority of those checks are appropriate for the vast majority of deployments. Now, even if you've got your configuration set up correctly and according to best practices, there is always the possibility that there's something wrong with Kubernetes itself that leaves it vulnerable to attack. And actually, in November, December time last year, we as a community found the first critical vulnerability in Kubernetes. It was discovered by Darren Shepherd from Rancher, and he wrote a really interesting blog post, if you're interested in the details, about how this particular vulnerability came to be, how he discovered it. It's a very interesting story, so I thoroughly recommend that blog post. But he reported that issue to the Kubernetes security team, which is a group of volunteers from across the community, and they responded quickly to get that addressed and to get a patch out for Kubernetes. So that was a really great result in many ways. It's inevitable that in a system as complicated as Kubernetes, there will be, some bugs, and some of those bugs will manifest as potential security holes, potential things for an attacker to exploit. And this was an example of something that had existed for quite a long time, but hadn't been, as far as we know, exploited by anybody in the field. And the good news was the Kubernetes security team addressed it really well. So we now know that that security response is really good within the Kubernetes community. From a user's point of view, the advice is keep up to date with Kubernetes releases. So long as you're running with the latest patched versions of Kubernetes, you won't have this vulnerability. You'll only have this problem if you're using an out-of-date release. And as Brice said earlier, not using deprecated software, keeping your software up to date, is a very important part of being as secure as you can. We've had other vulnerabilities reported in Kubernetes as well. This was an example of another fairly recent vulnerability. This one was not as severe, but again, you can avoid being vulnerable to this problem simply by keeping up to date with the most up-to-date releases. Now, I talked about following the best practices in the CIS guide, and there are a couple of things that are interesting conundrums that you may or may not want to follow the advice as it's laid out. One of the tests, one of the recommended benchmarks in that document says that you shouldn't allow privileged containers. The reality is that you will need to run privileged containers for certain components. If you're going to be running, for example, kubedns, it needs that privileged access. So arguably, that particular benchmark is overly strict, but you should think about that in the context of your own deployment. Another example where you may decide that you don't want to follow the guidance as laid out by the CIS is whether or not you allow anonymous access to the Kubernetes API. The current recommendation by the CIS is to disallow anonymous API access altogether. The problem with that is it prevents anonymous components, and this includes potentially control plane components, from doing health checks on each other without identifying themselves first. And the recommendation from many other experts in the Kubernetes community is that so long as you're using RBAC, role-based access control, and so long as you use RBAC to lock down what that anonymous access is allowed to do, and you keep that very tightly restricted to things like health checks and maybe metrics, then it's okay to allow anonymous API access. But you may want to look into that for your particular requirement, for your particular deployment, depending on other things like the network security that you have around your deployment. You may or may not want to allow anonymous API access. So that's an exercise for you to go and think about. So we've talked a little bit there about anonymous users, and that leads us neatly onto the question of authentication and authorization. So authentication is the step where you identify yourself as a user, or software identifies itself to the system. There isn't actually a first-class concept of user in Kubernetes. There is a thing called a service account, which is so that different application code or components of Kubernetes itself can identify themselves to the system. But as a user, Kubernetes relies on third-party systems, things like LDAP directories, to act as an identity provider, and it relies on the use of authentication plugins to interface with the Kubernetes system through the API server. Once you've identified yourself to the system, or your software has identified itself to the system, Kubernetes needs to determine whether you're authorized to make particular requests. So you may have permission to, you may or may not have permission to do the request that you're trying to do. That step is called authorization. There are a few different mechanisms for authorization within Kubernetes. The kubelet has a special node authorization to enable it to do what it needs to do. But as a Kubernetes administrator or an operator, what you're really interested in are, or should be, role-based access control and or webhook-based authorization. There was ABAC authorization, but that's kind of been considered pretty outdated for several releases now. So I hope you've all moved on to RBAC. Many of the current thinking around things like anonymous API access does assume that you are using RBAC and that you've got well configured RBAC settings. So that is something to pay some attention to. It is also possible to use things like OPA, the Open Policy Agent, and it uses the authorization webhook. So you could have some more complex rules either in complement to or to replace RBAC, but you do need to be very careful that you are restricting what in particular anonymous users can do. RBAC itself provides some abstractions between what we've called entity here, so that's a service account or a user or perhaps a group of users and groups being defined outside of Kubernetes. Those entities need to be given permissions to act on resources, and there are two abstractions between an entity and the resource that it can act on. So a role defines verbs and resources. It says what actions can be taken on a particular resource or set of resources. The role by itself says nothing about who can take those actions. And it's the role binding that links a role with the identities. So the role binding links together the fact that a particular user can take on a particular role and therefore do a certain set of actions on a certain set of resources. So now I want to move away from thinking about the Kubernetes control plane and move on to thinking about best practices in terms of the application code that you're going to run in your Kubernetes cluster. You're going to be running containerized software, and there are lots of best practices and good guidance that you can follow in terms of how you build those container images. One thing we see very commonly in organizations is that they have a limited set of base container images that they approve for use in their organization. So maybe there's a trusted Python-based image, and there's a trusted Java-based image, and they require the different development teams around the business to use those known base images that the security team's happy with. Another example of something you might want to have a policy around is not running as root, and we'll talk about this a couple more times before I get to the end of this presentation. But in a container image, or rather in the Docker file that you use to build a container image, you can define a non-root user that will be used to run. It will be the identity for running that container. The reason why that's important is that root inside a running container is the same as root on the host in today's environments. So while it's difficult to escape from a container, should that happen, should some vulnerability occur that means that an attacker can escape from a container, if they do that in the context of root within a container, they will be root on your host, and that would be a bad thing. So running your containers as non-root users is a much better idea. Brice already showed you vulnerability scanning. So he was using Microscanner to check the package to see what vulnerabilities exist in that image. And the screen shows an example screenshot from a scanner. This is actually also, this is a sort of HTML report that Microscanner can produce. Microscanner is a free version of Aqua's commercial scanner. So it's exactly the same scanner and it's using the same vulnerability database. The free version in Microscanner just doesn't do some of the other things that you might want to scan for, like looking for malware or sensitive data like credentials. I sometimes get asked, what would be the one thing that I should do to improve the security of my deployment? And I always say, use some kind of vulnerability scanner, whether it's from Aqua or from somebody else, because there are several solutions out there. Having knowledge of whether or not you're deploying vulnerable software is, I would say, the number one thing you can do to improve the security of your deployment. It's very good practice to use a private container image registry, whether that be your own hosted registry or perhaps using one of the managed registries if you're on a platform like AWS or Azure or Google. They all provide managed container registries that are effectively private. And then the last thing on this slide is talking about the best practice of being able to reproduce to the best you can a container image so that you can rebuild the image. Perhaps you need to patch one of the packages for a vulnerability version, but you want to know that all the other dependencies have stayed the same. There are projects like Google's Bazel that are quite interesting in terms of reproducible builds that may be worth looking into. So those are some ideas around best practices for the container images. We can also move on to talking about running the containers. As I mentioned, it would be a very good idea to run your containers as non-root users. You can enforce that at the Kubernetes level by the run as user policy, which could be part of a pod security policy, or I think it can also be defined in a pod spec. You might also want to use pod security policies to restrict what you can do in terms of volume mounting. If you mount sensitive volumes from your host into a container, you can effectively give that container escalated privileges. The extreme example would be if you mounted root from your host into the container, then your containerized application would be able to do anything it wanted on the entire of your host, and that would be a bad thing. So you may want to have policy around checking the volume mounts that each of your containers is permitted. that's something you could enforce through a tool like Aqua. You could also enforce it through things like the Open Policy Agent by writing some policies to enforce that. Network policy is another area that Kubernetes has first-class resources for defining some network policies that limit which pods can speak to each other. You'll find that commercial tools like Aqua will give you a finer level of granularity around that. And although it's strictly speaking outside the scope of Kubernetes, another approach is to use a service mesh like Istio. And then finally, you may want to consider running your pods under rules defined by things like seccomp or AppArmor, perhaps even SE Linux. And these Linux security modules, strictly speaking, seccomp isn't a security module, but they're all the same kind of Linux feature that restricts what a container can do in terms of the system calls that it's permitted to run with, and the in the case of AppArmor, things like the files it's allowed to access SE Linux too. So I talked about not running as root, and it's time to just look at a couple more recent Kubernetes vulnerabilities that have raised their heads in recent months. This one was a potential container escape, which is a pretty serious vulnerability. The solution to that is to keep up to date with Kubernetes releases. Again, this was an example where the security team did exactly what they needed to do and got a patch released. Very recently, this was in the last week or so, there's been this is a much less serious issue, but this is a case where if you have a container that runs as a non-root user, on the second attempt of running that user, or perhaps because of a restart, that container will actually run as root, even though you have defined it not to run as root. There isn't strictly a fix for this yet, but there is a workaround, which is to use the run as user policy that I mentioned earlier. The last aspect of security that I wanted to talk about briefly is secrets. So this is the credentials that your code might need to access things like databases. And they can be defined in Kubernetes as first-class secret objects. There are a few things to be aware of when we talk about secrets in Kubernetes. They're namespaced objects, and they provide the secret information into a pod as required by that pod through either a volume mount or an environment variable. And they are good in the sense of keeping the secret not written to disk. They will pass the secret in, even if you're using the volume mount, they're using a temporary file system, and that means it's held in memory, which is a good thing from the perspective of keeping a secret secret. Ideally, you never want to see a secret written to disk unencrypted. Now, having said that, the default storage mechanism for Kubernetes secrets is to store them in etcd, and by default they will not be encrypted. They will be base 64 encoded, but that just makes them hard for humans to read. It doesn't in any way actually encrypt them. So there are a couple of options. One is to encrypt the etcd database, and the other option is to use a third-party tool for storing your secrets. So to summarize, the kind of things that you can do to keep your Kubernetes cluster more secure, the most important thing is to keep it up to date and make sure that you're running with the latest security patches. You may want to use tools to check the configuration of your cluster and make sure that the settings are as secure as they can be. Use vulnerability scanning. As Brice showed you in his demo, it's pretty easy to add in to make sure that the software you're running, the applications you're running in your cluster don't contain vulnerabilities. Try to avoid running that software as root if you possibly can. Make sure you're using role-based access control to limit what users are allowed to do within your cluster, and try to give the minimum permissions possible to each user. And finally, manage your secrets, manage your credentials carefully. If you want more information on all of these aspects of Kubernetes security, there is a book that I wrote with Michael Hausenblas, who's at AWS, and you can, I think we have this as one of the handouts for this webinar, so hopefully it's available to you as a download. And I think with that, we're ready to take some questions.
Okay, thank you, Liz. Sorry, I just had to unmute myself. And yes, I do want to confirm that your O'Reilly Securing Kubernetes book is one of the handouts, so people can grab that today. And we do have quite a bit of questions here that have come in, so we'll try to get through these as quickly as possible. Just going to go in order of when they were received. So Brice, this was asked while you were presenting. The Kubernetes agent that was mentioned in the architecture design, is it Helm agent Tiller or customized agent created by Aqua?
So the agent is an open source agent called Flux. It's written by us at Weaveworks. We've had it open source for a really long time now, and actually most of the users are using the open source version. Flux works great. It has a component that will let you do the same kind of model but with Helm charts. So that's the agent I was talking about. I really should have mentioned it. My marketing team will be quite cross with me for not mentioning that the agent Flux.
Okay, great. Thank you for that. Liz, I think this one might be for you. Can Kubebench be run in an air-gapped environment?
Yes, absolutely. So you actually need to run Kubebench on each node in the cluster, which you could do. You could do it by SSHing into each node and running it directly there. You can deploy it as a job, and you want to schedule that on every node in the cluster. So yes, absolutely, you can run it. Now, the thing that is maybe harder to run in an air-gapped environment is another tool that we have called Kube Hunter. If you wanted to run that, you'd have to run that from inside the air-gapped environment. But kind of Kubebench by definition has to be run on the nodes you're trying to audit.
Okay, great, thank you. Current wisdom has it that we have to assume compromise. Is there a guide for incident response in case of a breach? And Brice, I'll have you take a stab at that first, and then Liz, if you have anything to add.
So, I mean, that's an amazingly good suggestion. I don't know of any such guide, but if it doesn't exist, it should exist. So I think that's a great suggestion. Maybe Liz can point us to a good resource.
Yeah, no, I'm not aware of a good guide, but I do think that's a very good idea. One sort of related thing that I've seen recently is that GitHub have produced some really good guides on how to handle security incident reports. Sorry, not incident reports, but reports of vulnerabilities that have been discovered. So there's a responsible disclosure process that good security researchers use, which basically involves when they find a flaw in a piece of software, they contact the maintainers of that software and they say, look, I found this problem, and they agree a time frame in which nobody will publish information about this problem because you want to give the maintainers time to come up with a fix. And then at the point where the problem is disclosed, there is also a fix available. And that's exactly the process that has happened with the exploits that I referred to earlier on. So those guides are certainly very helpful if you are, you're maintaining some software and you want to help people report security vulnerabilities to you in a responsible fashion.
Okay, great. Here's another one. What are the best practices to secure EKS control plane and custom data store for Kubernetes configurations other than etcd like S3 or Redis?
Okay, so the master node, if you're using EKS, you don't have access to the master node, and I think that's true for AKS and GKS as well. So one thing that you won't be able to do is run things like Kubebench on your master node, and because you don't have access to that node to check its configuration. I know that the vendors are actually CIS is working with the various different vendors to produce versions of that Kubernetes benchmark that give more guidance specifically for the different managed platforms. So watch this space for those.
Okay, great. So these two questions I think I'm going to combine. For the security of privileged containers, is it not possible to manage the credentials of the privileged container using an IAM solution that is container aware? And then does Aqua have an IAM solution to manage credentials for privileged containers?
Okay, I'm going to take those sort of in reverse order. So yes, Aqua has a solution that integrates with third-party IAM solutions to understand identity and then make sure that, there are two things you can use IAM for. One is the actual establishment of identity, and then you may also be using that to get credentials to access secrets from a key management store. So, for example, on Amazon, they have IAM and they have KMS, and the keys, the secrets that you're entitled to access depend on your IAM identity and all the configuration in IAM. So Aqua can use that information to ensure that the right pods, the right containers have access to the right credentials from that can then be stored in the KMS. And the advantage of doing that is that they're going to be encrypted, they're entirely private, they're off your Kubernetes cluster, and you don't have to worry about encrypting them because Amazon will do that for you. And I think the equivalent of that for GKE and for Azure as well.
Okay, thank you, Liz. You may have just answered this question, but I'm going to ask it anyway. Will Aqua also monitor EC2 instances, or is it kube focused?
So yeah, we do have some host checks that are built into the commercial product. So yeah, you can do things like scan for vulnerabilities on the hosts themselves. So this is the software that's running on the kind of underlying VM, if you like. So as well as scanning the containers that are running, you want to know that the host, the packages installed on the host are also not vulnerable. And yes, we do look after that as well.
Okay, next question is, how will it integrate with EKS?
By it, I'm gonna assume that it means Aqua, or maybe it means Brice. So why don't I answer it first, and then Brice can talk about GitOps in an EKS environment. So from Aqua's perspective, we're actually kind of agnostic to which platform it runs on. We do have certifications with various different platforms. Yeah, you install Aqua as it runs as containers, it runs as pods within your cluster. So it can run on basically any flavor of Kubernetes and also non-Kubernetes container environments. So I don't have anything specific to say about EKS other than that we do integrate with some of the kind of services that Amazon offer. As well as running on EKS, we integrate with things like the KMS and ECR, container registry, and so on. Brice, do you want to say anything about GitOps in an EKS environment?
Yeah, sure. Thank you. Yeah, absolutely. So we actually, so Weaveworks actually wrote the tool called EKS CTL, So the now default documented version adopted by Amazon to deploy EKS clusters is now EKS CTL, which is one of our open source projects. And that uses a configuration-driven approach to defining EKS clusters. So you would either define them in files in your local directory or create a Git repository with the definition of your cluster and point the tool at that Git repository. And then that would let you create clusters and provision clusters based on those configuration files. So if it's kind of configuration-driven management for EKS clusters, then absolutely just go and look up EKS CTL, and you should find what you need.
That's awesome.
Okay, great. Does AquaSec provide K8's audit services?
Okay, so that could mean a couple of things. So one of them would be auditing the configuration, which you can do using Kubebench, and Kubebench is actually built into the Aqua cloud native security platform, so you can get reports from a compliance perspective of things like Kubebench or the Docker configuration, the underlying Linux host, and so on. The other thing that you could be meaning when you're talking about auditing Kubernetes is providing audit logs when events happen. And this is a really fundamental part of, well, really any security platform, and Aqua in particular, where we provide an audit log, and it can integrate with whatever your SIEM system is that you're using, to log all the important events. So things like when a container starts, when a container stops, when a secret is accessed, when somebody attempts to do something that doesn't, well, when they do something that does meet your policy, but also audit logs for operations that are non-compliant. So perhaps you have an image policy that says you can only you can only deploy container images that have been scanned and that have passed, meet certain vulnerability criteria. And if someone attempted to deploy a container that wasn't scanned, that wasn't known to the system, you would get an audit alert for that kind of event. So yes, absolutely, auditing is a crucial part really of any security system. And I think Brice also mentioned earlier in his presentation about the fact that Git is storing records of every change. So that's another great way of essentially having audit logs, of having a record that you can use for kind of forensics in the event of something going wrong.
Yeah, those logs, those Git logs are actually, I mean, they've been used in practice to pass pretty stringent access control audit, Sarbanes-Oxley audits, these kind of things. So that they not just kind of internal security auditing, but also for external auditing of actions taken. And the auditors, the external auditors, tend to kind of be quite impressed when they see, here's a system, here's every single change, here's attribution for every change and a reason for the change being made. That tends to go down very well, and it's very useful.
Okay, great. We're basically out of time, and we probably have about 25 more questions. So I think what I'm going to do is make sure that I get these answered for everybody, but we're just going to have to take it offline at this point. I do want to say thank you to our speakers, and thank you to our audience for being so attentive and taking an hour out of your day to come and listen about Kubernetes security. And we welcome any other questions offline. You can certainly reach any of us, or you can just write to webinars@aquasec.com, and I can make sure they get into the hands of the right folks at Weaveworks as well as Aqua. But thanks everybody, and have a great rest of the day, and we hope to see you on another webinar soon. Bye now.
Thank you.
Thank you. Bye.
Transfer it back down.